Hi, welcome to DfRSoft's instructional video on shock and vibration on how to use the mod DfRSoft to do shock and vibration analysis. When you get to DfRSoft, you'll see the hyperlink menu area. So we'll go to the menu just to take a look at that. You have an open style menu here to find things. So there are some reliability tools at the top. And we have a lot of videos on all of these. There's a lot of help in DfRSoft. Here's our quality tools, things like design of experiments, lot sampling and stuff like that. Engineering tools is where we have the shock and vibration, and just below that is your physics of failure. So we're going to go to, all the modules are numbered in DfRSoft. And we're on module 25, so we can hyperlink to that. And here we are on that module. And there's also in this module, there's a lot of tools on shock and vibration, and they're also listed at the top, so you can find them that way as well. So and here's the video that we're doing. So there's also pop-up instructions. So you have the video that you can click on, and the examples under each section to explain what things are. So the first area that we'll be interested in is the sign calculator. And for example, if you know your displacement, say it's 9 mils peak to peak, and you're interested in a particular frequency, say 60 hertz, across the row here, it'll give you your velocity, your acceleration, and your displacement again. If you know your peak G's, say it's 50 G's, across that row it'll give you the information of the velocity, and there's your acceleration again, and also your acceleration in meters per second squared. So it makes it very easy to figure out things like that. The next area of interest is the constant acceleration analysis. This is when things are spinning around at a high angular velocity in a constant accelerator. If you know the radius of the arm and the G level that you're looking at, it'll get you your RPM requirements, or vice versa. If you know your RPM, and you can enter that and the radius, and it'll get you the G level. Another area of interest, sometimes people are interested to know if wire bonds are going to be damaged under a high G level. So you can put the weight of the wire bond and the G level, and what DfRSoft does is it gives you an equivalent pull force. So you can estimate it in that sense. So that's a pretty interesting way of doing it. Now the next area is shock. This is a very important calculator, and all these things are important. Like in the sine vibration, you want to know if your shaker limits and things like that, or if you want to specify a test. So we have two areas for mechanical drop and electrodynamic shaker shock. So here's your drop area. So under mechanical drop, you enter basically you're just entering your G level, your pulse duration, and also a calibration rebound type of factor, which there's some guidance here in the pop-up. Typically, if you don't know what it is, you put in 1 for a default. And but when you can calibrate your equipment, and that becomes a little bit more helpful to be more accurate for your particular equipment. And then it gives you the drop height for half sine, triangle, sawtooth, rectangular, as well as on the ED. For an ED shaker, it also gives you your stroke distance and haversine and triangle and sawtooth velocities in inches per second, and as well as the peak-to-peak displacement. And that's important in case you want to make sure that you can perform the test on your shaker. So the next area down, we also have some packaging guidelines for foam thicknesses so that you protect your product. One of the very popular analysis areas is random vibration. Let me zoom out a little bit on that. And we have a spec in there right now, and this is our power. For whatever spec you have, you can enter it into DfRSoft. We always enter things in the green squares. And so basically for this area here, what you want to do is you want to make sure you put in your maximum ED slope that your power PSD shaker can handle. DfRSoft has in there a default of 60 dB per octave, which is typical maximum slope that a lot of shakers have. So that helps you out, and then you can put in your what it does is you can put in your frequency, and you can enter your PSD levels for each frequency. And if your slope is basically, if your slope is too high, DfRSoft makes it tells you what frequency you should be using or for your shaker requirements to meet that slope requirement. And then after that, it gives you for that PSD spectrum your GRMS content in the spectrum, your maximum peak-to-peak displacement, and it allows you to know what your shaker, if you're exceeding your shaker limits, gives you the maximum displacement that is likely for the probability. For example, this is because we're in random vibration, there's always a probability for your displacement rather than an absolute number like sine vibration. So here, this 0.45 inches will occur about 0.006% of the time. And your maximum velocity, the same thing, and so it does that for a few different probabilities. And also of interest, more people today are doing SignOn Random. So down below, you can enter your sine tones into the spectrum. So whatever you've entered here, you can add sine tones to it, and DfRSoft will give you the new spectrum and your displacements and GRMS content and things like that for that to also get an idea if your shaker will exceed the limits with what probability that'll occur. The next area down is for sine search resonance. Usually you scan up and down, so you put in the rate that you're going, your rate that you're going to go at in octaves per minute, your low frequency, your high frequency, and your also you can put in your resonance frequency, and it'll tell you how many octaves you're going to do, as well as the time it's going to take you to do that. And also it tells you if you're going at a reasonable rate to resolve that resonance. So the next area down is very important. This calculator for the maximum electrodynamic shaker force pounds is important because you don't want to overload your shaker, so you put in your maximum load in force pounds that the shaker is rated to, the weight that you're going to do in the G level, and it'll tell you whether your load is okay or not, or if you're over. Next is the simple vibration calculator, where you put in your Q value, your resonance frequency, and your G level, and it'll tell you your input in peak-to-peak displacement, your input at resonance, and things of that nature. The next area is your vibration fatigue acceleration model, so that this area here is for when you're doing your entry is in G or GRMS. This is your PSD level when you're using G squared per hertz. Sometimes we use GRMS, so you can also use this area here. If you're using the GRMS area, your acceleration model, you want to for G's and GRMS, your output will be over here. Your acceleration factor in the years equivalent for that, and the G squared per hertz would be on this area right here. And of course, you have your instruction information and the model information as well. Random vibration XYZ fatigue acceleration model, so you can also do both input in G squared per hertz or GRMS level, and you enter that for your XYZ type of testing, and it'll give you your results in your X, Y, and Z axis and the total test time for that. Now, here's an interesting area. You can't really relate sign testing to random testing, but sometimes we have old test specs and we want to do it, or we are forced to do that. And there's some intelligence here on what people have done in the literature and the model information that's provided. So if you're desperately needing to convert a sign test to random or vice versa, you have an idea how to go about that and get a good intelligent estimate of what that would be. The next area is the chi-squared vibration analysis area. So if you were doing testing, you can enter your sample size. We have a number of accelerated test plans that can help you do that as well. The next area is the circuit board component fatigue life model, a Steinberg model. And this is an interesting calculator, and there's a lot of help here. So it basically tells you on your circuit board life information, and it's a little more complicated to use than most, and the model information is provided, but it's certainly worth understanding the Steinberg method. We teach that as well for circuit boards, and you can learn about that quite easily. Now, the next area is if you're doing minus rule for fatigue life. You have the ability to do that in DfRSoft and estimate. You have to put in the cycles to failure for each one, as well as how many cycles you've done for each stress level. We also have the ability to do acceleration factors. So if you know the cycles to failure at one stress level, it'll predict the cycles to failure at the other stress levels, with knowledge of your acceleration factors for that. The next area of interest, let me zoom out on here, is our isolation design. The first thing DfRSoft does is it plots your resonance information for you. So you put in your resonance, your initial and your final value, and the Q of the resonance. It'll give you your damping information, your maximum transmissibility, the isolation frequency region, and basically your time constant, and it gives you the the transmissibility curves for that, both in one's in dB and the other is in transmissibility regular units of input over output, and or percentage. Rather, the transmissibility also gives you the percent of isolation that will occur after the isolation region. And down below is where you can do your estimate your spring stiffness. You put in your forcing frequency, your weight, and your transmissibility in percent, and it'll give you your spring stiffness required, isolation in percent, static deflection, things of that nature, and you can also put it in terms of static deflection in inches and weight and transmissibility, and it'll give you the spring constant that way. Another area of concern is what is your sampling rate to capture a vibration data when you're taking information in the field. So this area here, this estimate will help you do that, and you can put in information such as your high frequency of interest, your lines of resolution, your observation time. You can enter your resonance frequency and your Q estimation, and it gets you an idea of the your suggested sampling rate, sampling bandwidth, the number of samples, and things like that. We also have a vibration wear model calculator, so you can estimate your acceleration factors if you're doing wear. So this is a very new model that we've added for that. So those are all the tools that are available to you for vibration analysis in DfRSoft. And thank you for listening. We certainly enjoy providing this information for you. And as we mentioned, we all have the theory of everything in design assurance in one tool. In DfRSoft, we try to provide you all the tools that you need to do design assurance. So you have all the tools right at your fingertips. And